Okay, chapter 9, guys. Polar coordinates. That's where we're at here. And we're going to break this into two sections. 9.1a, we'll talk about polar coordinates. All right, so what is a polar coordinate system? First, let's talk about that. So it's a coordinate system in which the location of a point is identified by polar coordinates. So a little bit different than what you've worked with when we talked about like an XY coordinate system. That's like a basic one, polar coordinates. And they're in this form r comma theta. So r is going to be the distance from the center, and then, or we call the center the pole to the given point, and then theta, of course, is the angle measure that's formed by what we call the polar axis. That's like your x-axis in this case, polar axis, and a line from the pole through the point. Okay, so polar axis. All right. So kind of think about more like a circular coordinate axis system rather than, your flat XY rectangular one. Your polar axis, we talked about, that's the initial ray from the pole. It's usually horizontal and usually directed towards the right. So before we go into graphing them, let's just take a look at the diagram here, what the polar coordinate system looks like, okay? So we talked about here would be your polar axis, right? It's the kind of like an x-axis. It's just horizontal and to the right. Okay, that goes out that direction there. And then we talked about how your distance here, you've got your point r theta, and r is your distance right here between your pole, which is your center point, and that point there. And then the other coordinate would be the angle right here. So that's kind of what you're looking at in the system. All right, so let's go back up now when we talk about graphing these. We'll talk about how to graph them, and then we'll talk about what that looks like on the grid. So graphing polar coordinates, you've got positive angles. They rotate counterclockwise. So kind of like we've done when we're measuring angles and things like that, we go counterclockwise. And negative angles, just like the unit circle, they're going to go clockwise. And the point lies on the ray opposite of the terminal side. So regular positive angles do the same thing. They're going to go counterclockwise. Negative angles are a little bit trickier, though, because they're going to go counterclockwise, but then the ray on the opposite side of theta. So we'll kind of talk about that as you go. You're going to kind of draw a line through the pole to get your measurement there. All right, so what do? We're going to label our radius and our angle measure, because R basically stands for radius, right? That's, since we're dealing circular stuff, right? Since we're dealing circular things, this distance from here to here, R, would be considered kind of a radius of a circle, right? Okay, so let's keep going now. And just to remember, if you want to convert radians to degrees, that's going to be available to you. Just make sure you multiply by 180 over pi. And then you can find, and obviously the opposite, if you want to find radians, pi over 180, reciprocate to get radians from degrees. All right, so let's find, to graph one with a negative r value, so a negative angle, graph, or a negative measurement, right? Graph the angle measure, then extend its terminal side to plot the point with its corresponding value. So we'll kind of show you examples of those and tell you what we mean. Okay, so now let's take a look at like the polar grid here. Okay, so we did already look at the polar coordinate system. Let's look at the grid. Okay, so in this case, if you put it on a graph on the grid like this, you can see that you've got your polar axis is here, right? But in this case, we've got an angle going out this direction, a radius of r here. And then you've got theta is your angle right here. And so our point, our theta, would be there on the graph. Okay, so let's practice a little bit. Let's graph each point here. Okay, so on these first ones, actually, I'm not even going to use these polar coordinates. I'm going to make it look like this system here, the polar coordinate system. Okay, so we won't even use these. I think I should have just not even included them on here. Okay, but I know they were on your sheet to begin with, so whatever. So we can actually just draw these with an XY axis here, and just kind of make them circular. So if I just look at this first one here and say, all right, we've got -1 and pi over 2. Okay, -1 and pi over 2. All right, so in this case, what we're looking at, remember, it's a negative R value. So just pointing that out, that I've got a negative R value here. So that'll be just like we talked about right here. Okay, so graph the angle measure, then extend it through the terminal side with the corresponding angle. Okay, so in this case, what we're doing is I'm thinking pi over 2. If I'm thinking radians, right, pi over 2 is 90 degrees, so pi over 2 is up here. And so my angle measure is basically going to be up to this point here. Okay, that's going to be my theta. That's pi over 2 angle. Okay, and then what I'm going to do for it's a -1. So I'm actually going to take my vector and extend it through here, my vector or my radius down this way, and that just kind of show that it's a distance of 1 from here to here, and that would be the point -1 pi over 2. Okay, because we have to extend it to the other side. All right, the other two are positive, so that's not so bad. So I'm going to kind of go on this one. We'll say 2.5 and 240. So I'm just going to scribble these out a little bit more, just so we know we're not really messing with these. Okay, right now we will on the next page. Okay, but 2.5 and 240. All right, so 2.5 and 240. So I got to find my angle measure. All right, so 240 is going to put me all the way across to about here, right? It's going to come 90, that's 180. 240 is going to be right here. Okay, that's going to be 240 degrees. And then I've got to go 2.5 in this direction. Okay, and just kind of show that I've got a point right here. That would be 2.5 comma 240. Okay, and I'm just going to kind of show that my distance here, have something that just shows, okay, from here to here is 2.5 units long. That's all I have to do. Okay, notice I'm still kind of on a downward angle here with, going below the x-axis here. That's okay, even though this is positive, right? It's positive because my angle took me there. My angle took me to 240, which is different from number 1, right? Number 1 was negative. My angle took me up here, but because it was negative, I got to extend it through the pole to the other side corresponding. Okay? All right, and another one is just positive here, so we can just do that one here. This one is 4 and -5/6. So now we have a negative angle on this one. So all we're going to do here is we're going to find that angle first. Okay, so -5/6 is actually going to take us, negative pi would be all the way over 180. So -5/6 is going to kind of take us all the way to about here. Just kind of guesstimating, okay? And you can always turn that into radians if you'd like, right? I mean, it doesn't have to be. And then we have a +4. So we've got my angle, and then my +4 is just going to be coming from here and just give me a radius of 4. And that would be 4 and -5 over 6 pi. Okay? And again, just maybe show this distance is 4 to give us that the angle. We've got the distance of 4, so then that becomes my point there. So kind of simple. The only tricky one is if you have a negative R value, you find that angle first, then go opposite that, which we'll do some examples of as we go. Now let's look at the polar grid. Okay, so now let's actually graph it on the polar grid ones. Okay, so for this one, so now you'll get a good idea of what it would look like. So you're at negative are 1.5 and negative 7/6 pi. Okay. Well, I may want to convert this to radians here, right? Because negative 7/6 pi, if I multiply that, and you can do that. It's a little strategy you can do to help you out here if you want to. Okay, so if we do that, and sometimes it helps us do that. If we don't like radians, and we can say, okay, well, I want to look at, especially because my grid here has degrees on it. I can give you stuff with radians, but this would be negative 210 degrees. Okay, so when I do that, if I'm coming from 0, my angle here is going to take us from negative 210. So I'm going to have to go back this way. That's 180, and I need 30 more, so it's going to be about right here. So that's my angle measure. And then I got to go 1.5. Okay. So in that case, what I'm doing is here I am, but I'm going 1.5. So I'm actually going to take, this is my 0 out this way. So I'm going to go up here a distance of 1.5. Now, this, you actually have your grid, right? I've got this first circle here is 1, and then 1.5 would take me about here. I'm actually going to do that in a separate color just to make it pop, if you will. So I'm going to take it from here, and I go 1, and then 0.5 there would be my point right there. Okay, so that would be this point right there. Okay, and I guess if I want to make full angle, I can color that blue. All right, so next one, negative 2 and negative 135. It's already in degrees for you. So I'm going to go ahead and do my angle first. So starting here, and I've got negative 2. So I'm just going to say negative 135 is going to be at 225. Is that right? Yep. So I'm going to go back this way. 225, right? 90 would be here. And another 45 would take me there because I've got to go negative. So that's my negative 135. Okay, from here. And then I'm going 2, right? So 2. We'll do that in green here. So now from here on that angle, here's my angle. I'm going to go 1 circle, 2 circles. So that's a point of 2. Just went a little too far. So I'm just going to go 1, 2, and there I am. Okay, and that would be my graph. Now, the tricky thing is that would be if it was positive 2, that's where I'm going, but it's negative 2. Okay, so technically I have to go the other direction. I have to go to this angle, but I got to work through the other side, which would be 45. So I'd be up here, would actually be my negative 2. I'm going to take this angle. Start with that angle, but then I got to go through to the other side because it was a negative value. Okay. All right. The next stuff here, we can read through this really quick. In a rectangular coordinate system, each point has a unique set of coordinates. That's not necessarily true in a polar coordinate system, right? So we have that rectangular one. That's our basic one. You know that each point has an x and y. It's not necessarily the case here in polar coordinates. So we remember back in chapter 4, we talked about how the given angle has infinitely many coterminal angles, right? If you keep going around in a circle, you'd get to the same point. Every time you repeat it in the circle, you'd be at that point, right? So like I said here, we could show it really quick. If you're at this point, right, that's one point. But if I go around the circle one time, that's another point. If I go around again, that's a third point. So I can keep going around and get multiple points there. And that just kind of shows you where it's at, okay? So generally what we can say is that if we have a point that is r comma theta, then it has polar coordinates of r theta plus 360, right? So if I just add 360 to that point, I'm going to get another one. So if this was, say, a 45-degree angle, or let's make it easier. Let's say this was a 30-degree angle. Well, if I went all the way around, then I'd be at 360 plus 30, 390 would also be the same point. So it just kind of shows that. Okay. Also, With radians, it also works. Okay, radians is the same thing. Just instead of 360, it's 2 pi. Okay, and then same. You can also subtract there, right? It's plus or minus. You can do the same thing the other direction, going around the other way. So that just kind of gives us this thing here. So plus or minus 360 would be the same point. Like I said, if I just went from here, and then this is my point, but if I just said, oh, if I just go all the way around the circle that way, I'm subtracting 360 from whatever I got, and there you go. Okay? All right. Same thing now, because if it's negative r, remember just from graphing those, that what it does is it actually takes your graph and takes it to the opposite point, right? So if it had a negative degree measure, it's going to go through into the other side. So technically, if I took from here and I went 180 degrees, I would be at the same point. So if you're using a negative r value, because you go through that pole, you could say plus or minus 180 or plus or minus pi. So basically, you're just saying if I have a positive r value, I can add or subtract 360, and I'll get the same values. And if I have a negative r value, then I can go plus or minus 180 or pi, right? So kind of doing that. And then we've got all these things in there that are written that basically make the same thing in that paragraph. So I'm just, and these bottom examples, just want you to point out, if you got a positive r, just add or subtract 180, a negative r, or sorry, add or subtract 360, and a negative r, you can add or subtract 180, and you'll get points that are additional pairs. So that's what we're going to do on this one, 3a and 3b. So I'm actually going to do 3b first here, because, well, you'll see when we get there, but 3b first. So 2 and pi over 6. All right, so if I know that 2 is positive, right? So if I just say that if I'm going with 2 as my r value, then pi over 6, since I'm dealing with radians, plus or minus 2 pi would give me a same point. So I'm going to go minus 2 pi here. So that just means that 2 comma, it would be negative 4 pi over 6. So I guess you could reduce even further, but that's fine with me there. Okay, I'm just subtracting 2 pi from pi over 6. Now, I can also, since I want 3 additional pairs, I can use a negative value of this as well. So if I say that I want to go with negative 2, okay, then that just means I'm going to take my pi over 6 and I'm going to add or subtract 180, or in this case, since we're dealing with radians, I'm going to add or subtract pi. So let's subtract pi. And so then I get negative 2, and then it would be negative 5 pi over 6. And the same thing, if I go ahead and just say, I'm going to use negative 2 again, but this time I'm going to go pi over 6 plus 180, or plus pi, since I'm dealing with radians, I'm going to get a point of negative 2 comma 7 pi over 6, and those are all 3 equivalent to this initial point. They're the same basic coordinates, because you're just going around the circle that many times. Okay, so let's go back to 3a, because 3a has one that you kind of have to use what we did in 3b to get 3a. So again, if I just take this initial point and I say 5 comma 240, and then I add or subtract 360. So in this case, I'm going to subtract 360, and I'm going to get 5 comma negative 120. Okay, so now let's use that negative 5 idea. I'll just change colors here just for the point of doing negative. So if I use negative 5 instead, then I'm going to add or subtract 180. Okay, so 240 minus 180 gives me negative 5, and 60 would be at the same point. Okay, all right, now conversely, since that's the same point, I could actually use this and add or subtract what we got here. So because that's the same point, in this case, I could go 60 and then, minus 360. And I could do that because I'm just kind of taking that point, which is the same as this one, right? And to get negative 5 and 300. Just showing you a negative 300, just showing you a different way to get those points. Obviously, I could take this and add 180 here and get another one as well. But then you're going to get a number above 360. So then sometimes because you have to go between 2 pi and pi, negative 2 pi and pi, and between negative 360 and 360. If I did that here and I added 240 plus 180, I'd be over 360, which is not in my limits here. So I can't do that. So that's why I had to kind of take a point and subtract 360 from it here. Okay. Which is a little confusing, but I can take this point and move it down here. And because this point is equal to this point, technically it's a positive R value. And then I could add or subtract 360. Again, I'd have to subtract because if I added it, I would be over 360. It's the same thing there. I can't add it to be over. Okay. Same reason I can't just go here and add 360 because of this here. I've got to be between those numbers. So sometimes I have to get creative with how to do that. I took this and moved. Now I know it's a negative R value here. And we said, okay, you know, negative R values, you add or subtract 360. But because this point is essentially the same as this point and this point, technically I would go around the whole circle again. That's why I did 360 instead of 180 there. Okay, so I hope that helps. If you have questions, I'll try to clear that up a little bit more tomorrow. That is 9-1 polar coordinates, 9-1A.